What is up, guys? My name is Heinrich and welcome to Bardent. Today we're going to take a look at creating super basic enemies that can detect ledges, as you can see on the left, and detect walls like this one on the right. We'll also make it so that we can hit them, and then when they die they will burst into a couple of chunks and some blood splatter that will eventually disappear. Okay, so let's start off by importing the sprites that we're going to use. So let's go to the sprites folder. And let's just do some organization. So we'll create a new folder. I'm going to call it player. And I'm just going to drag all the player related sprites into this folder. Like that. And then I'm going to create another folder. I'm going to call this one enemies. And we'll drag the dummy sprite sheet into there. And I'm going to create another folder that I'm going to call... I'm going to call it maps. I'm just going to drag the decor items and the tile set into that. And then finally, I'm going to create one last folder that I'm going to call particles. I'll just drag the particles into there. Okay, let's go into the enemies folder and let's import our new, enemy sprite sheet. And we'll start off by just changing the settings like we always do. So the pixels per unit is 16, the sprite mode is multiple, the filter mode is point no filter, and we'll set compression to none and then hit apply. We can then click on sprite editor and hit slice, grid by cell size, and the pixel size is 64 by 64, and then hit slice. And then we can hit apply. Now we have all of the sprites for our enemy. We can now create our enemy game object. So we'll create a new empty game object. And I'm just going to call this enemy1. And now very important is reset your transform. We can then come to our enemy1 game object and create a new child game object that we'll call alive. This will be the game object that all the different components are attached to. And our script will be attached to enemy1. So on the alive game object, let's click add component and let's start by adding a sprite renderer. And into this sprite renderer, we can drag the first sprite just so we can see where the player is or the enemy is. And then we can come to the sorting layer and change that to enemy. And we'll just leave it on 0 by default. Next, we can add a rigidbody 2D component. And in this component, we need to set the gravity scale to 8 or to whatever you set everything else to, or whatever works best for you. And we'll change the collision detection mode to continuous. And then we're going to freeze the Z rotation. Next, we're going to add an animator component. And we'll just leave that as it is for now. And then finally, we're going to add a box collider 2D component. We can open that up and just hit edit collider. And let's go ahead and change it so it fits around the enemy a bit better. Just like that. Okay. I'm also just going to click on the enemy1 game object and then drag him up here where it makes a bit more sense to have him. Just like that. Now we just need to make sure we click on the alive game object again and set the tag to enemy and the layer to damageable. Now we can start to make the animations. So let's go to the animations folder. And in the animation controllers folder, let's right click and create a new animator controller. And I'm just going to call it basic enemy AC. I'll then click on the alive game object and drag this new controller into the animator. We can then go to our animations folder and just create a new folder that we'll call enemies. We can then drag up our animations window and click on our alive game object and then create a new animation. Navigate to the enemies folder we just created and we'll call the first one enemy1 underscore walk. We can then change the sample rate to 15 and then go to our sprites folder and drag in the first 8 sprites, so from 0 to 7 into this animation. Look at him go. Okay. Next, we can make the hurt animation. So we'll say create new clip and then call this one enemy1 underscore hurt. And this one only has one sprite and it is sprite 13. So we'll drag that in there If you play it, it doesn't look like much, but this adds a lot. Okay, so we can take away the animations window now, and then we can just go to our animator and click on our alive game object, and then we'll create one parameter that we need for now, and this will be a boolean, and we'll just call it knockback, like that. We then want to make sure that our default animation state is our enemy1 walk state, and then we want to make a transition from any state to our hurt state. I want to click on it and make sure has exit time is not ticked, and then under settings we want to change the transition duration to 0. We'll then come down to conditions and add the condition that knockback is true, and then we'll make a transition from our enemy1 hurt state to our walk state, and we'll do the same thing. So make sure has exit time is not ticked and the transition duration is 0, and then under conditions knockback must be false. This is all we need for the animations for now. Later on, as we improve the AI of the enemy and add more states, this will become a bit more complex. But for now, all the enemy does is walk and get hurt. So let's go into our scene view and then head into our scripts folder. In here, let's again make a new folder that we'll call player, and then just drag all the player related scripts into that folder. And then we'll make another folder called enemies, and we'll drag the combat dummy script into that, and then we'll make one last folder called particles, and we'll drag this particle controller script in there. Let's head into our enemy script and create a new C# script that we'll just call basic enemy controller. Let's open that up in Visual Studio. And we can just start off by deleting the code that is pre-generated for us. So the way the enemy behavior is going to work is we're going to use what is called a state machine, meaning we're going to have a bunch of predefined states that we'll use to determine what behavior the enemy must have. And this will make it really easy for us to expand on the enemy later and add more behaviors and more states to it. To keep track of the different types of states that we have, we're going to use what is called an enum. So to declare the enum, we'll say private enum, and we're just going to call it state. We can then open it with a squiggly bracket, and then inside the brackets, we can name all the different states that we have. So our first state will be walking. We can then use a comma to separate the different states, and the next state is knockback. And then finally, we'll have the dead state. It's important that the last state does not have a comma after it. We also do not need a semicolon after any of the lines. Next, we need to come down and declare a private state called current state. This will keep track of what our current state is. The same thing can basically be achieved using integers. So you can say like walking equals 1, knockback equals 2, dead equals 3, but the enum basically replaces that in a more readable way. We're going to have 3 functions for each of our states: an enter function, an update function, and an exit function. So let's come down and just make little comments so we know which state we're working with. So we'll say walking state, like that. And then we'll say private void enter walking state. And then next we have a private void update walking state. And then finally we have a private void exit walking state. Like that. And now we just need to do that 2 more times for our knockback state and our dead state. So now what we're going to do is we're just going to come up and create the update function. And inside the update function, we're going to determine which state is currently active, and then based on that, call the different update functions for the different states. And we'll do this using a switch statement. So we'll say switch, and inside the brackets, we will say current state, and then we'll open up some squiggly brackets. And basically what this does is it says, based on what current state is, here are a bunch of different things you can do depending on what it is. And the way you do this is you say case, and then the condition, so state dot walking, and then you put a colon, and then on the next line you say what needs to happen. So if our current state is walking, we're going to call update walking state, and then we put in a break like that, and then our next case is state dot knockback, and if that's the case, we're going to update the knockback state, put another break, and then our final case for now is state.dead. And if that's the case, we'll update dead state. And then put one final break. So basically, depending on what current state is, all the other code for the different states will get ignored, except for the state that we're currently in. Now we need to write a function that will take care of swapping between the different states. So let's come down below all the states, and let's just make a different section in the code called other functions, where we'll write all the other important functions. So this function is private void, and we'll call it switch state. And this function is going to take a parameter, and that is the state we want to swap to. So it's going to be a state, and we'll just call it state with a lowercase s. Inside the function, we're going to have two more switch case statements, and the first one is going to take care of calling the exit function for the current state, and the next one is going to take care of calling the enter function for the state we want to go into. So we'll say switch, and this is based off of current state, and our first case is going to be, again, state.walking, and if that's the case, we're going to say exit walking state, and then we'll put a break, and then our next case is state.knockback, and if that's the case, we will exit the knockback state, and then put a break. Finally, we have case state.dead, exit dead state, and then a break. Now we can just copy this switch statement so we don't have to write it all out again. But this time, instead of using current state, we'll just use state, which is the input parameter to this function. And instead of calling exit, we'll call enter for each of them. And you might be wondering why we have an enter and exit state for the dead state. The reason we're going to have that is just if we end up using object pooling, or if we have things that respawn the enemies, stuff like that. We'll get to that later. For now, when the enemy dies, we're just going to destroy the game object, and then we'll work on the respawn system later. And now finally for this function, we just need to change current state to our state. Okay, so now we're going to work on the movement of the enemy. We're going to get it to turn around when it reaches a ledge by just having a little ground check raycast downwards, and then we're going to get it to turn around at a wall by just having a little wall check raycast, like we have lots of experience doing with the player controller already. So let's actually go up to the top and declare some variables. We'll firstly need two booleans. So they will be private bool, and the first one is going to be ground detected, and the second one is going to be wall detected. We then also need two transforms where these two raycasts will be. So we'll come up and we'll say serialize field, and this will be private transform, and the first one will be ground check, and the second one will be wall check, like that. We then also need a serialized field, and this will be a private layer mask, what is ground. We also need to declare the distances for these rays, so we'll create another serialized field, and this time it'll be private float, and the first one will be ground check distance, and the second one is wall check distance, like that. We can then come to our update walking function. We'll say ground detected equals physics2d dot raycast, and the position of the raycast is ground check, and the direction is vector2 dot down, because we always want the ray to shoot down, and then our distance will be ground check distance, and our layer mask is what is ground, like that. Oops, ground check is supposed to be ground check dot position. And then we can do the same for the wall check, so we'll say wall detected equals physics2d dot raycast wall check dot position, but this time we'll use transform dot right, because we always want the raycast to shoot out at the front of the enemy. And then next we have wall check distance, and then finally what is ground. Now, based on the information from these rays, we will say if not ground detected, meaning the raycast shooting down is not detecting any ground, or wall detected. So if ground detected is false, or if wall detected is true, then we need to flip the enemy. Else, we need to move the enemy. So let's start with the flip function. All we need for that is a private int facing direction. So we'll say private int facing direction. And then we can come down to our other functions section, and we can write private void flip, like that. I don't know why I did this. And inside the function, we can just say facing direction times equals -1, and then we can say, oops, okay. And then we need to get a reference to our alive game object, which is the one that actually holds the sprites and the one that will be moving around. So let's come back up to the top, and let's declare a private game object that we'll call alive. And then we just really need to come and write our start function. And in this, we'll say alive equals transform dot bind alive dot game object. And then back in our flip function, we can say alive dot transform dot rotate, and we'll rotate it 0.0f, 180.0f, and 0.0f, like that. That's our flip function done. So let's come back to our update walking state and just call flip from here. Now to move the enemy, we need to get a reference to its rigid body component. So let's go back up to the top, and under this, let's declare a private rigid body 2D called live RB. And then in here, or in the start function, we can say alive RB equals alive dot get component of type rigid body 2D. Now that we have this reference, we can come back up to our serialized field private floats and declare a movement speed. And we can also come below our ints and say private vector2, and we'll call this movement. What we're going to do is just update the values of movement to apply to the rigid body's velocity instead of declaring a new vector2 every time we update it. So let's go back to our walking state, and in here we can say movement.set, and now we can just specify an x and y value for it, and the x is going to be movement speed multiplied by facing direction, and then our y is just going to be alive rb dot velocity dot y, like that. And then we just need to say alive rb dot velocity equals movement. Now we just need to remember in start to set our facing direction to 1 by default. Next we can work on damaging the enemy and then the transition to our knockback state. So let's declare the variables we need for that. First we need another float, and this one will be max health, and then we also need another float that's not serialized, and it'll be called current health. We can then also declare some variables for our knockback state, when we'll start off with a private float that will be the start time of the knockback. So we'll say knockback start. Ooh, I cannot type. Knockback start time, and then we'll have a serialized field private float that will be knockback duration. And then finally we need to make another serialized field. This time it'll be private vector2, and it'll be called knockback speed. This will allow us to specify the x and y speeds in one variable. So let's come down to our other functions section, and let's declare the damage function. So we'll say private void damage, and this is the same as the damage function we had on the dummy, with one small difference. And we're going to make the difference to the dummy and the player code later. Instead of taking in int or float damage amount, we're going to take a float array called attack details. So we'll say float, and then square brackets to specify that it's an array, and we'll call it attack details. The reason we do this is because we use the send message function when we hit something. The send message function only allows us to send one parameter in. So if we want to send multiple parameters through, we have to do it like this. And the reason we need multiple parameters is because we're going to be sending through the attack damage, but we're also going to send through the X location of the person doing the attack. That way we know which side of us the enemy is standing on and which way we need to get knocked back. So inside the damage function, we can then say current health minus equals attack details 0. So we're always going to send the attack damage in the first index of the array, and then we're going to send the X position of the player in the second index of the array. And actually, now that I think about it, we need another variable that is going to be a private int as well. And this int is going to be called damage direction. And now back in our damage function, we can determine what damage direction is by saying if attack details 1 is greater than alive.transform.position.x, then that means that the X position of our player is greater than the X position of our enemy, meaning the player should be facing the enemy, meaning damage direction should equal -1. And then else, we can just set damage direction to 1 by default. Like that. Now in here we can take care of instantiating our hit particle when the enemy gets hit, but we'll take care of all the particles later. So we'll just say hit particle, like that. But now we need to make the enemy go into the knockback state. So we'll say if current health is greater than 0.0f, meaning the enemy is still alive, we'll say switch state dot knockback. And while we're here, we might as well say else if current health is less than or equal to 0.0f, then switch state to state.dead, like that. So let's go to our knockback state, and in the enter knockback state, here we'll say knockback start time equals time.time. So this will keep track of the exact time when the knockback started. Then we'll say movement.set, set, and we'll use knockback speed.x multiplied with damage direction as the x component, and knockback speed.y as the y component. Then we just need to set the velocity, so we'll say alive RB dot velocity equals movement. Here we also need to take care of transitioning in the animator. So let's go get a reference to the animator component. So we'll come up to the variables and say private animator, and we'll just call it alive anim. We'll get the component in start, so we'll say alive anim equals alive.getComponent of type animator, like that. And then in the enter knockback state function, we'll say alive anim.set bool, and the bool we're setting is knockback, and we're setting it to true. We then also just want to come to the exit knockback state function and say alive anim.set bool, and this time we just want to set knockback equal to false, like that. Now inside the update knockback state function, we'll say if time.time is greater than or equal to knockback start time plus knockback duration, meaning the knockback has gone on for long enough. We just need to switch states back to moving. So we'll say switch state dot walking. I actually don't like the fact that I called it walking, so I'm just going to change it to moving over here. So moving, 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 and we want to change it from walking to moving. And lastly, don't forget doing it at the bottom, just like that. Okay, now everything is better. And that's it for our knockback state. Now let's look at our dead state. So what we can do is just, for now, in enter dead, here's where we would spawn the chunks and the bloods particle. So let's just say spawn chunks and blood, but we'll get to that later. And then we can just destroy the game object. So we'll say destroy game object, like that. Now before we head back to Unity, let's just call our onDrawGizmos function so that we can see our ground and wall check raycasts. So we'll say onDrawGizmos, like that. And we'll just say gizmos.drawLine, and we want to draw the line from groundCheck.position to a new vector2, and the x for this vector2 is going to be groundCheck.position.x, and the y is going to be groundCheck.position.y minus groundCheckDistance. And then our wall check is going to be gizmos.drawLine from wallCheck.position to a new vector2, and we'll use wallCheck.position.x for the x plus wallCheckDistance, and then just wallCheck.position.y for the y. So if we save this, I think we're ready to head back into Unity. So in Unity, if we now click on our alive game object, we can just go ahead and create a new empty game object that we'll call ground check, and another one called wall check. If we then click on our enemy1 game object, we can drag on our basic enemy controller script. And then we can drag in our ground check position and our wall check position. We can set what is ground to ground if I can find it. And then we can change our ground check distance to 0.5 and our wall check distance to 0.1. And now we can just move these game objects and position them a little bit better. So we'll move the ground check to just in front of the enemy and the wall check to just in front of the enemy as well, like that. Okay, now we can click on enemy1 again and we can just set the movement speed to 3. I'm going to set max health to 30, and then knockback duration I'm going to set to 0.1. Knockback speed I'm going to set to 10 on the X and 5 on the Y. And if we run the game now, it should work. You can see our enemy moves and then flips when he reaches a ledge. We are not yet able to actually damage the enemy because we just need to go make a few changes to our player combat controller. But let's quickly test the enemy on the walls as well. So let's just move him down here. Let's go take a look. And as you can see, he turns around when he touches a wall as well. If we try and hit him, we're going to get an error. Okay, so let's go ahead and fix that error. What we need to do is go to our player scripts and open up our player combat controller script, and then come up to the top, and then we're going to declare a new private float. But this time it's going to be an array, and we'll call it attack details. And then we just need to say equals a new float array of size 2. That means that our attack details array is going to have 2 indexes. We can then come down to our check attack hitbox function, and inside of this we'll just say attack details 0 equals attack 1 damage, and attack details 1 equals transform.position.x. And now here where we say collider.transform.parent.sendMessage, instead of saying attack 1 damage, we're just going to say attack details. If we go back to Unity now, we should be able to damage the enemy. As you can see, the enemy instantly dies. Why? Oh, I know why. We have to come back to our basic enemy controller, and very important, in our start function, don't forget to set current health equal to max health. Like that. So now if we hit our enemy, you can see he gets knocked back and then eventually dies. Okay, now let's make the particles for when we hit the enemy. So the first particle, when we strike the enemy but he does not die, we'll just go to our prefabs folder, click on our hit particle, and then hit Control D. We can then rename this to, say, enemy 1 hit particle. And then I'm just going to mess around with the colors in the sprite renderer. And I'm just going to make it the same color as part of the enemy. Now it looks a bit more like a blood splatter. We can then come back to our basic enemy controller script and declare a variable to hold a reference to our particles. So let's say serialize field, and we're going to have a private game object, and we're going to have 3 of them. The first one's just going to be hit particle, and the second one is going to be death chunk particle, and the last one is going to be death blood particle, like that. We can then come back down to our damage function, And then after we subtract the health, we can instantiate the particle. So we'll say instantiate, and we want to instantiate the hit particle. And we want to instantiate it on alive.transform.position. And we want to instantiate it at a random rotation. So we'll say quaternion.Euler. And the Euler is going to be 0.0f for the x, 0.0f for the y. And then for the z, we're going to say random.range. We're going to take this between 0 and 360. So if we save this and head back into Unity, we can then click on enemy 1 and then drag this hit particle into the reference slot. Let's just move our enemy back up closer to us so we don't have to run down every time. And then if we run this, we should be able to damage the enemy with a lovely little blood splatter. Okay, now let's make the chunks and blood that happen when we kill the enemy. So let's head to our sprites folder, and in the particles folder, let's drag in our pieces sprite sheet. We can then click on it and just do what we usually do. Pixels per unit is 16, sprite mode is multiple, filter mode is point no filter, compression is none, and then hit apply. We can then click on the sprite editor and just choose whichever chunk you like best. I like this one, so I'm just gonna click in the one corner and drag a little green box around it. We have now cut this sprite out from the rest of them. We can then hit apply. Let's come to our hierarchy and then right click, go to effects and say particle system. Zoom in on the particle system and start off by coming to the renderer tab and just setting the sorting layer to enemy. I'm going to set the ordering layer to 2 so it appears above the enemy sprite. Okay, we can then close the renderer tab, and now let's make it use the chunk as the texture. So come to texture sheet animation, click the little circle to activate it, and then change the mode from grid to sprites. Drag the piece of sprite into the little block right below it. We can then open up our emissions tab, and then change the rate over time from 10 to 0, because we want to use bursts instead. So click the little plus symbol in the burst section, and we'll just change the count to a random number. So we'll click on the little arrow and say random between 2 constants. And we'll just say between 50 and 70. Let me expand this so you can see that. If we restart this, you can see it. A little burst of particles. It doesn't look like much yet, but you'll see we'll get there. We can then come to our shape tab. We'll change this from a cone to a circle. As you can see, it looks more like a line and not much like a circle. Just come up to the top at the transform and change the rotation from -90 to 0. Now the circle faces us. Perfect. We also want to just reset the transform so everything else is 0. Okay, now let's make it look a little bit better. We'll start off by setting a start delay. We'll change it to random between 2 constants, and we'll have a start delay of between 0 and 0.1. That spreads them out a little bit. We can then also change our start lifetime, change it to a random between 2 constants, and we'll just have the lifetime be between 2 and 5 seconds. Let's also change the start speed to a random between 2 constants, and the speed is going to be between 10 and 15. Now we get a much better explosion effect. Perfect. Now let's change the start size, again, a random between 2 constants, and the start size will be between 0.1 and 0.5. You just need to play with these numbers to make the chunks look a reasonable size for your character. Now let's mess with the start rotation. So we'll say random between 2 constants, and we'll just have a rotation of between 0 and 360 degrees. That looks a lot better so far. We can then come down to our stop action and just set that to destroy. That means when this particle system is done playing, the game object will destroy itself. So also just make sure to untick looping at the top. Now let's make it so the particles are affected by gravity. So come down to the gravity modifier and just change that to 8. If we play this now, you can see the particles pop up and fall down. You can mess with this to make it feel a bit more floaty. I'm actually going to take mine down to 5. If we restart this now, it explodes a bit nicer. We can also just drag the particle system above the enemy so we can take a better look. Also, you can notice these little screen tearing lines. If you want to fix that, just mess with the size of the window and it'll eventually go away, just like that. So that looks quite good. Now let's make the particles interact with the environment. So scroll down and come to the collisions window, or the collisions tab. Hit the little circle to turn it on and change the type from planes to world. We then need to change it from collides with everything to nothing, and then change that back to ground. We also need to change the mode from 3D to 2D. It's almost perfect. We can then just change dampen to 1 and bounce to 0. That means when the particles hit the surface, they stick to it and they lose their momentum. We can then also just come back to our shape and just change the size of the circle to make it fit in the enemy a bit better, like that. I like it. The last thing we need to do now is just rename it. So we'll call this death chunk particle, and then just reset its transform one last time. Before we make it a prefab, just click on it and hit Control D. We'll rename this duplicate that we just made to death blood particle. And then just drag the death chunk particle into the prefabs folder and the death blood particle into the prefabs folder as well. We can go ahead and delete the death chunk particle game object from the hierarchy, and let's work with the blood particle. Let's go back to our sprites folder, and in our particles folder, let's click on the pieces sprite sheet again and hit the sprite editor. And for the blood, I'm actually just going to use a single pixel. So I'm just going to drag around a single pixel and then hit apply. We can then come to our death blood particles again, and under texture sheet animation, change the 2 sprites around. So we play this now. You can see the pieces are a bit big. So let's come up to our start size and let's change that from 0.1 to 0.05 to 0.1. As you can see, that looks a lot better. Now we just need to come to emissions and change the count between 250 and 500. So there's a lot more blood to go around. 500 might be a bit much. I'm going to take this down to 400. Perfect. We can then also come to our start color and then hit random between 2 colors, and we can just mess with the color a little bit. I'm going to make the blood a little bit brighter red and between a little bit of a darker red. So we play this now. That looks good. Okay, let's make sure we save the changes we just made to the prefab by coming up here, hitting overrides and saying apply all. We can now delete the death blood particle from the hierarchy and then head to our script, and in our enter death state function, we can instantiate these particles. So we'll say instantiate, and we're going to start with the death chunks particle. And we're just going to do it on alive.transform.position. And the rotation is going to be death chunk particle.transform.rotation. And then we can do the same with the blood. So death blood particle alive.transform.position death blood particle .transform.rotation, just like that. And now we just need to make sure on enemy 1 that we drag in these prefabs into the game object slots. So death blood particle into death blood particle, and death chunk particle into death chunk particle. So now if we kill the enemy, beautiful. If you want the chunks to despawn faster, you just need to mess around with the start lifetime variable over here. And that's going to do it for now. Next, we're going to take a look at making the enemy damage the player when the player touches it. Before I go, I just want to fix a mistake I made with the dash ability. So if we play the game and we dash, as you can see, we can see the dash perfectly fine. But I built the game and I played it and I realized I could not see the dash. And I was like, why is this happening? And I realized it's because when you build the game, the frame rate is a lot higher. And I did not think of this when I wrote the code. But if we head to our player after image sprite script, our alpha is getting multiplied by something every single update. Meaning this alpha is not going to decay at the same rate every time. It's very dependent on frame rate. So let's fix this. Let's quickly put a serialize field for our alpha multiplier. And let's actually change it from alpha multiplier to alpha decay. And then in our update, instead of saying times equal, we'll say minus equals alpha decay times time dot delta time. So now when we play the game, we need to come to our after image prefab, and the alpha decay needs to be set to something higher. I found that 10 works good for me. Now the after image will decay at the same rate every time. I hope you guys found that video helpful. If you have any questions, feel free to leave it in the comment section, or you guys can come join the Discord and talk to me directly. And a big thanks to all the supporters and wonderful people on Patreon, and an absolute big thanks to the absolute mad lad Mason Crow for his support. I hope you guys all have a wonderful day.